Hey everybody, today we're going to talk about how to find the volume of a cylinder. And if you think back to last week when we were working on surface area, those formulas were pretty long. This formula today is a really nice short one. I think you're going to like this. To find the volume, first of all, when we're talking about volume, we're really referring to the capacity of this cylinder. How much could it hold if you were to fill it up with sand, water, pudding? I mean, you could fill it with anything really. How much space is there inside of the figure. And to do that, we're going to find the area of the base. Now, if you take a look here, hopefully you can see the base is in the shape of a circle. I'll just go ahead and shade this in here so you can see here. We'll find the area of this base here, and then we're going to multiply that by the height of the cylinder. Now the base is a circle, so you can see big B stands for the area of the base. We use this formula here, pi r squared, to find the area of a circle. Pi r squared. Hopefully you remember that. If not, it's in your packet, and you should be taking really good notes as I'm going through these examples. So to find our volume, here's our formula. We take pi r squared and we multiply that by h, the height of the cylinder, and that's it. Isn't that a nice short formula this time? A lot shorter than the ones we used for surface area. All right, so here I have a cylinder, and first of all, what we need to notice here is this 4-inch measurement right here is the radius. I know it's the radius because it's only going from the center of the circle to the outside of the circle. Okay, so that is the radius right there. And so if I want to find the volume, I take pi r squared, r is your radius, times h, the height of this cylinder. Now this measurement here, the 7 inches, is the height of the cylinder. It's the distance between these bases, which are circles. And remember, just like with prisms, your bases have to be parallel to each other, and these circles are parallel. So, and there is a height of 7 inches. The distance between them is 7 inches. Now you'll notice I do have some arrows over here. And so I'm just going to go ahead and show you what I have shown off to the side here. To find the volume, you could find it in terms of pi. Some people think, well, that's kind of confusing, but actually it's less work for us. Instead of using 3.14 in place of pi, we're just going to call it pi. And then in place of the r, we need to substitute in 4 because that's your radius. So you see I've got a 4 right here, squared, and then times h, which is the 7 right here. Okay, and then you can use a calculator here. 4 squared, 4 times 4 is 16, and 16 times 7, here I need to get my marker up here again, make sure I have a smaller size here. If you do 16 times 7, you get what? 112? (16 times 7 is 112. And then we still have to take that times the pi. And so we can call the volume 112 times pi cubic inches. Okay? I'm going to talk a little bit more about why we would do this in just a little bit. Okay? But you'll see it is less work because I didn't have to put 3.14 in here in place of the pi, even though that's usually what we use for our value of pi. All right, now if you look over here, we could use the value of pi from the calculator. Now, normally I would say, hey, use 3.14 in place of your value for pi. Okay? And so you'd take 3.14 times 4 squared times 7. Okay? So that's 3.14 times 16 times 7. Honestly, we already know 16 times 7 is 112. So you could just take 112 times 3.14, and you get a value of 351.9 to the nearest 10. I do want to talk about these labels. See how they're cubic inches? When we were doing surface area, it was always square units. But volume, we're talking 3 dimensions. And so it's cubic units. So your label always needs to have an exponent of 3 there. And it looks like inches cubed, and you can say inches cubed. But normally, I like to say cubic inches. Okay, so 351.9 cubic inches. Or you could say 112 times pi cubic inches. Now, the reason a person might want to give this in terms of pi instead of giving it like this as a decimal is because once you put something in for pi, like 3.14, for example, you've rounded. Because pi isn't 3.14. It's 3.1415926535. It's irrational. The decimals keep going on and on and on. So the second you round to something, like in this case 3.14, you're going to get an approximation of the volume. Okay? So this over here, giving it in terms of pi, is actually the most precise way to give the volume because we are not rounding anything that we're putting in place of the pi. Okay? All right, so that's why sometimes we would just do it like that in terms of pi. So if you're ever asked to give the volume in terms of pi, that's what it's saying is just don't put 3.14 or anything else in for pi. Just solve this part and show it being taken times pi. Okay? All right, let's look at example 1 here. I see I have a 5 centimeter measurement here. This is your radius. How do I know? Because it's going from the center of the circle to the outside of the circle. If it were going all the way across, that would be the diameter. Okay, this is your radius. And this right here is your height of your cylinder. It's the distance between those bases. So my first step is always the same. Write down the formula. Volume equals pi r squared h. All right, I'm going to find the volume here in terms of pi. Let's find it in terms of pi. So I don't need to put anything in for pi. I'm just going to leave it as pi. Times, all right, what's r? Well, we know that's 5 centimeters. So it's times 5 squared, and then times h, which we see here is 8.3. Okay? So now all you have to do is use your calculator, take 5 squared, which is 25, multiply that by 8.3. I'm doing that off camera right now. I get 207.5 here when I calculate all this over here. So 207.5 times pi, and it's cubic centimeters. That's the volume of this cylinder when I express it in terms of pi. Now, if you want to give this answer in decimal form, then you would have to fill a 3.14 in for pi. So you would take 3.14 times 5 squared times 8.3. Or you could just take 3.14 times 207.5. Since we already found that part. Okay, and I'm going to do that on my calculator quickly. You can do the same thing on your calculator, see if you get the same result. I get 651.55. And since I'm working with centimeters here, my label will be cubic centimeters. Remember, volume is always cubic units. You need a 3 here for your exponent. Okay? Both of these answers are great. This one is more precise, but this one is a little bit more useful having it in decimal form. Okay? Sometimes all we need to do is get it in terms of pi because, well, depending on what you're trying to find after this, this form might work well for you as well. And this is more accurate since we didn't round pi to anything. All right, now in this one it says find the volume of this cylinder, and it says round to the nearest tenth. If we're rounding to the nearest tenth, then we must not be leaving it in terms of pi. We must be actually finding the decimal value. So we will use 3.14 for pi. If it doesn't tell us what to use for pi, we will use 3.14. And then I'm going to write my formula down. V equals pi r squared times h. Isn't that a nice formula? Seriously, it's so short and quick. And then we just fill in our values. Pi is 3.14 times r, that's given over here. 1.5 centimeters. See how it's just going from the center of the circle to the outside of the circle? Squared times h, and your height is the distance between these circles, which is 8 centimeters. Okay, so now I'm going to use my calculator, and I'm going to take 3.14 times 1.5 squared, and then times 8. And I get 56.52 for an answer. Check it on your calculators. Did you get the same result? It's important that you try it on your calculators as I'm going through this, because then you'll know if you're using your calculator correctly or not. Now, back in the directions, it said to round to the nearest tenth. So it's going to be just 56.5. And I put the squiggly equal sign to mean about or approximately equal to 56.5 cubic centimeters. Because it is volume, it has to be cubic units. The reason we did not round up to a 6 here is because this 2 is not large enough to make that round up. This would have to be 5 or more to make this soar. So yeah, 56.5 cubic centimeters is our answer to the nearest tenth. All right, find the volume of a cylinder with a diameter of 16 inches and a height of 20 inches, and express your answer in terms of pi. All right, so let's write our formula down. V equals pi r squared h. And again, since we're doing this in terms of pi, I'm not going to put anything in for pi. I'm just going to call that pi times. Now, what is our radius? We have to be careful here because this time we're given the diameter. The diameter is 16 inches. When you're looking at a circle, the diameter goes all the way across the circle. So if that's 16 inches, the radius would be half of that, which is 8 inches. So we have to be careful that we're using the right number here. Our radius is 8 inches. So it's pi times 8 squared times, and then our height, it says, is 20 inches. Okay, again, we're expressing in terms of pi, so don't put anything in for pi. Just take 8 squared, 64, times 20, which is 1,280, and then it's times pi. And then a label, we're working with inches here, so I'm going to put inches cubed, cubic inches, 1,280 cubic inches, and that would be my volume. Okay, because of time, I just want to jump ahead and do one more problem here, because this one takes it one step farther than the ones we've done so far. Here we have a metal paperweight in the shape of a cylinder. The paperweight has a height of 1.5 inches. Here it is right here. And a diameter of 2 inches. If the diameter is 2 inches, can you tell me the radius? Well, the radius would be 1 inch. And I'll tell you this, if your radius is ever 1 inch, it makes things a lot easier when solving the problem. How much does the paperweight weigh if 1 cubic inch of metal weighs 1.8 ounces? Round to the nearest tenth. So I actually have to find my volume first here. Volume equals pi r squared h. We write our formula down. And we're going to do this to the nearest tenth. So we're going to use 3.14 for pi times the radius squared. Well, our radius is only 1 inch. Remember, the diameter is 2. The radius is 1. So times 1 squared, and then times the height, which is 1.5. Do you know what 1 squared is? 1 times 1 is 1, isn't it? 3.14 times 1 is still 3.14. So really all I have to do is take 3.14 times 1.5. And so I'm going to do that. 3.14 times 1.5, that's 4.71 cubic inches. That's my volume. Now, is that the answer to the question? No. How much does the paperweight weigh if 1 cubic inch, we have 4.71 cubic inches here, of metal weighs 1.8 ounces? So I need to take 4.71 times 1.8. I'm about to run out of time in the video here, but if you multiply those together, it equals 8.478 to the nearest tenth, 8.5 ounces.